All right, ladies and gentlemen, in today's video, we are going to begin the journey into square numbers and eventually to their square roots. Let's talk about squaring numbers. 1 times 1 equals 1. So 1 squared equals 1. Now, how did I accomplish that goal of writing down 1 squared equals 1? We have to talk about what a square is. So it's useful to draw one. If I draw a square, remember all of their sides are of equal length. Okay? I might be butchering the physical geometry here, but you get the picture. In this case, the side lengths of the square are just 1. So 1 times 1 is 1 squared. And 1 times 1, so when I square it, I just get 1. And that's the only value where that happens. I suppose 0. It also happens with 0. 0 squared is 0. But let's look at another number, just so we got 1 out of the way. Now let's look at a number like 8. Okay, so 8 squared is equal to 8 times 8. Here's an important point. Any number or any base, okay, these whatever is in this position is called a base. Right now it's a number like 8. Later it will be a letter like X or Y. These base values, unless otherwise indicated, have an exponent of 1. So here's what's going on behind the scenes. One of the rules of exponents is if you multiply two numbers with the same bases, in this case the base is 8, then you just write the base again and you add the exponents. So in this case we're adding 1 plus 1. So 8 raised to the power of 1 plus 1 can be simplified to 8 raised to the power of 2. 8 squared. But that's not all we can do with a number like 8. Let's take 8 again and prime factor it. What is the smallest prime number that is a factor of 8? Well, it's an even number, so the smallest prime factor is 2. 2 times what equals 8? 2 times 4. 4 is not prime, so we continue to factor. And the factors of 4 are both prime numbers, and they're both 2. So we can rewrite 8 as, so we'll rewrite 8 as 2 times 2 times 2. And remember, the unwritten exponent is 1. So we can rewrite 8 as 2 raised to the 1 plus 1 plus 1 power, or 2 to the third power. And this is called 2 cubed. Now, let's say you want to do some math and you want to multiply 8 times 8. We all know what that equals. 8 times 8 equals 64. But we want to work on this from the level of primes. So instead of writing 8 times 8, we can write 2 times 2 times 2. That's 8. 2 times 2 is 4 times 2 is 8. And then we're going to multiply it again by 8. So we just continue multiplying by 3 more 2's. Okay, and remember, each one of these has a 1 as the unwritten exponent, and there are 6 of them. So we rewrite the base of 2 and whatever number of them that there are, 1, 2, 3, 4, 5, 6. So 2 to the 6th power is equal to 8 times 8. All right, so let's do this. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 8 times 8 equals 2 raised to the 6th power, and 8 times 8 and 2 to the 6th power equal 64. But that's not all. We could also group these numbers in any way we wish. In this case, I'd like to group them in pairs of 2. And there's a reason for this. So, rather than writing 8 times 8, we will write 2 times 2 times 2 times 2 times 2 times 2, but there's a simpler way to write even this string of 2's. We can recognize that we have these pairs, okay? 2 times 2 is certainly 4, but remember we're working here with the exponents of 1, so I can write 2, just for this pair right here parenthetically, raised to the 1 plus 1, or 2 squared. So I'm going to rewrite 8 times 8 as 2 squared times 2 squared times 2 squared. And I still have 6 2's. Here are 2 of them, here are 2 of them, and here are 2 of them. Just multiply together. I didn't change anything about the problem. I just changed how I'm grouping the prime factors. So where does this become helpful? Well, when we take square roots, and we're looking ahead here, when we take square roots, let's say you're asked to take the square root of 64. When we take a square root, there's an unwritten 2 here as the index. This is called an index, and this square root symbol is called a radical. Okay, a radical sign. The number underneath the square root is called the radicand. R-A-D-I-C-A-N-D. This is the radical, and this is the radicand. This 2 is the index. Okay? Well, rather than just take the square root of 64, and here, just as a note, we're only working with positive roots. We'll get to negative roots later. Instead of just taking the square root of 64, I'm going to substitute this triplet of squared 2's. So let's rewrite the radical sign, and this time give it a long arm. And underneath that radical, I'll write 2 squared times 2 squared times 2 squared. And remember, when I do this, I'm taking the square root. That means that there's an index of 2. Now that turns out to be extremely important. Whenever your index matches your exponent, okay, see how those are all 2's? You can simplify the radical, because the square root of 2 squared times 2 squared times 2 squared is equal to the square root of 2 squared times the square root of 2 squared times the square root of 2 squared. Okay, and remember, all along, the index is 2, 2, 2. They all still match. Here's the index, here's the exponent. Index, exponent. Index, exponent. When those indexes and exponents match, you can eliminate the square root and simplify this radical and radicand down to just a whole number, okay, to whatever the base is. So if I've got these matching, then the second root of any base squared is just that base. In this case, the square root of 2 squared is 2 times the square root of 2 squared is 2 times the square root of 2 squared is 2. Remember, we're taking the square root of 64 here. Let me just rewrite that so we haven't forgotten what we're doing. And now I have the square root of 64 equals positive result only, 2 times 2 times 2. Well, let's recombine those numbers. 2 times 2 is 4, times 2 is 8. You already knew that because you have memorized how to take the square root of 64. Okay, that's called a principal root, and it's something you've probably been doing for years. But now you understand a little bit more of the complexity behind the scenes, and you've learned something about exponents. Well, I hope this video has been interesting to you, a different way of doing something. We are going to be using this frequently in Algebra 1. So if this video was helpful, please give it a like. If you have a question, please leave a comment. And if you have not already, please subscribe to the channel and hit that notification bell so you are always alerted to new videos on this channel. Thank you.